Hello Gators, this is 7-4 Similarity in Right Triangles. I can use similarity and the geometric mean to solve problems involving right triangles. Let's first talk about a proportion. A proportion is made up of two ratios. And when the two ratios are equal to each other, we call the placement of numbers in these two spots the mean, and the placement of two numbers in these two spots the extreme. Now, when the mean values are exactly the same, we call this a geometric or a mean proportional or geometric mean. And this is always going to happen when these two values are exactly the same. And when they're exactly the same, we can cross multiply and we'll get x squared equal to a times b. And then we can take the square root, and we want the positive square root because mean proportional is always going to be a positive number. And this is how we solve for x. Let's go ahead and do a problem. Let's find the mean proportional between 2 and 18. Okay, mean proportional means the two mean values are exactly the same and we're looking for them, so we're going to call them x. And then we're going to cross multiply. That will be x squared is equal to 36. Take the square root of both sides, that's plus or minus 6. But you only want the positive value for the mean proportional. So the answer is 6. And if you want to check your answer, put 6 here and 6 here, and you can see that when you cross multiply, the answer is 36. Okay, let's go ahead and do a problem here. I am going to set up my proportion. It's asking for the geometric mean, so the mean values are not known, so I'm going to call them x and x. They're both the same. And then I'm going to say 6 and 12. Okay, I'm going to cross multiply, so this is going to be x squared is equal to 6 times 12. And now I'm going to take the square root of both sides. And when I take the square root of both sides, I'm going to notice that 12 is really 6 times 2. And here I have 6 times 6, so the simplification will be 6 root 2. And that will be my geometric mean. Let's take a look at a right triangle where we draw an altitude. When we draw an altitude, we're going to create 3 right triangles. We're going to create the large one, ABC, large, and we're going to create a small one and a medium one. I want you to notice that in the medium and the large, they both share angle A, so angle A and angle A, which means that these two triangles right here will be similar by angle-angle similarity. Okay, now let's change color and let me take a look at the small triangle. The small triangle and the big triangle have angle B in common. So here's angle B. So I know that these two triangles will be similar by angle-angle similarity. And by the transitive property, since these two are similar and these two are similar, then they're all similar to each other. So all the triangles are similar. And that's what our next theorem says. Our next theorem says that if you have a right triangle and you draw an altitude to the hypotenuse, then you're going to create 3 triangles, the large one, the medium one. Remember, the right angle is at D, so I'm going to put a D here and a D here. And the medium triangle shares angle B, and then this will have to be a C. And the small triangle shares angle A with the big triangle, so this will be angle A, and the only other letter to work with is C. So this is how we set up the triangles when we want to look at them. And they're all going to be similar by angle-angle similarity. Let's see if we can do it on our own here. I have a big triangle and I'm going to put all the right angles in the same place. So this is going to be P, and then I'm going to have A and then T. And that's my big triangle. Now my medium triangle, remember the right angle is at R. Now this is the medium triangle, and the medium triangle shares angle T with the big triangle, so I'm going to put a T here. And the only other letter left to use in that is P. Now I'm going to work with a small triangle. I know that it has a right angle here. And angle A in the small triangle is the same as angle A in the big triangle, so I'm going to put an A right here. And the only other letter left is P. So I have redraw the three similar triangles created, and I can actually write out the similarity statement. APT is similar to triangle PRT, which is similar to triangle ARP. And make sure that all the right angles here are in the same place, and the angles that are being shared are in the same place. Okay, now we're looking at this situation right here. I want to zero in on the small triangle and the medium triangle right here, the small triangle and the medium triangle. And I want you to notice that when triangles are similar, their sides are in proportion. And so the shorter leg right here, BD, is to the shorter leg here, as the longer leg here, CD, is to the longer leg here. So this is very interesting because this is a geometric mean. Notice that these mean values are the same. So this is going to lead to our next theorem, which says that between these two triangles, the shorter leg of CBD is to the shorter leg of ACD, as the longer leg to the longer leg. And again, this is a geometric mean. And so the theorem is going to actually refer to this CD as an altitude, and it's going to refer to the fact that we do have a geometric mean, and it's going to refer to these lengths right here. Instead of calling them shorter leg and longer leg, we're going to refer to them as side and side. So the theorem is going to be really using these words. Instead of saying shorter leg and longer leg, we're going to say altitude is the geometric mean between the lengths of the side 1 and side 2. Let's take a look at this theorem and see if it can't help us figure out what CD is. I'm going to call that X right here. So I have a right triangle, and I can see that my altitude is X, and I can see one side is 5 and one side is 15. I'm going to cross multiply. 5 times 15 equals X squared, and I'm going to write 15 as 5 times 3, and now I'm going to take the square root. And when I take a square root, I can see that I have this double factor, which I can take out of the square root. 5 square root of 3 is equal to X, and that will be my X, my altitude. Let's do it one more time. I'm going to look for the altitude here, and so I'm going to write down everything I know here. The altitude is my X, that's the geometric mean, and 4 and 20. So I'm going to multiply 4 times 20 is equal to X squared, and 20 can be written as 4 times 5, and I'm going to take the square root, and when I take the square root, I can see I can take out a 4. That's going to be a perfect square, and then that'll be X. So here's my geometric mean. So what we've learned is two theorems. We've learned that when you draw an altitude to a hypotenuse, you're going to create 3 triangles. They will all be similar to each other right here. And that this altitude right here, this altitude, is going to be the geometric mean between this side and this side. Those are the 2 theorems we have learned.